Всем привет. Продолжаем JavaScript. Сегодня у нас Object-Oriented Principles. At this point, you will have learned and had a chance to practice the more common object creation and organization patterns in JavaScript, but that is just the tip of the iceberg. More important than learning the syntax for factory functions or modules is figuring out how to use them effectively. This whole series of lessons has been about the object-oriented programming paradigm. The basics of creating objects and classes are relatively straightforward, but it's not straightforward to decide what to put in each object, or when to make a new object, or when to let an object inherit from another object. This section explain the single responsibility principle, briefly explain the additional solid principles, explain what tightly coupled objects are and why we want to avoid them. Explain what tightly coupled objects are and why we want to avoid them. Luckily, there are several concepts and principles that can guide us into making good decisions when it comes to our objects. You guys making a decision when it comes to our object. The lesson is introduction to the most important of those concepts. Keep in mind that there is not a usually very clear answer to your application design questions. Some patterns and ideas are obviously better than others. There is often some trade-off when deciding where to put specific. As you read this resources might help to go back into some projects you already done, and there's a resource might help to go back to some projects you have already done, and think about how what you have written measures up to the examples you see. And of course, as you move on, keep these things in mind when crafting new projects. Single responsibility. As you craft your object, one of the most important things to remember is the single responsibility principle, which states that a class or object or module you get the point should only have one responsibility. This doesn't mean that an object can only do one thing, but it does mean that everything an object does should be part of the of one responsibility. Here's a really common example. Most of our code has functions to update and write things to the DOM in addition to our application logic. It's a really good idea to separate your DOM stuff from the application logic. So instead of this, div game, you should extract all of the DOM manipulation its own module and use it like so. In fact, the function game is game over shouldn't be calling the dump function. Anyway, this should go elsewhere directly in the game loop. Another way to think about the single responsibility principle is that a given method class covenant should have a single reason to change. Otherwise, if an object is trying to have multiple responsibilities, changing one aspect may affect another. The single responsibility principle is the first of a commonly found set of 5 design principles called the solid principles. You'll read more about these principles in the assignment articles below. Loosely coupled objects. Obviously, all of our objects are intended to work together to form our final application. You should take care, however, to make sure that your individual objects can stand alone as much as possible. Tightly coupled objects are objects that rely so heavily on each other that removing or changing one will mean that you have to completely change another one in a real bummer. This one is related pretty strongly to a single responsibility but takes a different angle. As an example, if you were writing a game and wanted to completely change how the user interface worked, you should be able to do that without completely reworking the game logic. So we should be able to start overwriting our game using primarily console log, and then add a bunch of DOM functions later without touching the game logic. But takes a different as an example, if you're writing a game and want to completely change how the user interface works, we should be able to do that without completely revoking the game logic. So we should be able to start off writing our game using primarily console logs and then add a bunch of DOM functions later without touching the game logic. The following articles mention the acronym SOLID. Before going on to talk about single responsibility. Single responsibility is definitely the most relevant of the 5. Feel free to dig into the rest of the SOLID principles if you like. But pay special attention to single responsibility. The single responsibility principle. This principle does make use of jQuery, one of the earliest and most popular JavaScript libraries prior to the ES6 standard. While the Odin project does not teach jQuery and you are not expected to understand the example, be sure to focus less on the code itself and more on the solid concepts being expressed. Solid JavaScript is a single responsibility principle. This is the first installment of the Solid JavaScript series, which will which will explore the solid design principles within the context of the JavaScript language. In this first installment, we'll take a look at what principles comprise the solid design principles and discuss the first of these principles, the single responsibility principle. The solid design principles in JavaScript. The solid is мнематический, acronym referring to a collection. Что это значит вообще? Order of letters, ideas, or associations that assist in remembering something. Понял. Acronym referring to a collection of design principles which evolved out of the object-oriented community and were popularized by the writings of Robert C. Martin. These principles are as follows: the single responsibility principle, the open-closed principle, the Liskov substitution principle, the interface segregation principle, the dependency inversion principle. These principles are often discussed within the context of classical statically typed object-oriented languages, and while JavaScript is a prototype-based, dynamically typed language bleeding concepts from both object-oriented and functional paradigms, programmers can still reap the benefits from the application of these principles of JavaScript. This article will cover the first of these principles. The single responsibility principle. The single responsibility principle relates to the functional relatedness of the elements of a module. This principle states a class should have only one reason to change. This description can be a little misleading as it would seem to suggest that an object should only do one thing. What is meant by this assertion however, is that an object should have a cohesive set of behaviors together, comprising a single responsibility that, if change, would require the modification of the object's definition, or simply an object's definition should only have to be modified due to changes to a single responsibility within the system. Приверженность. The single responsibility principle helps to improve maintainability by limiting the responsibilities of an object to those which change for related reasons. When an object encapsulates multiple responsibilities, changes to the object for one of the responsibilities can negatively impact the others. By decoupling such responsibilities, we can create code that is more resilient to change. Adherence to single responsibility principle helps to improve maintainability by limiting the responsibilities of an object to those which change for related reasons. To those which change for related reasons. When an object encapsulates multiple responsibilities, changes to the object for one of the responsibilities can negatively impact the others. By decoupling such responsibilities, we can create code that is more resilient to changes. How do we identify whether a given set of behaviors constitutes a single responsibility? Would grouping all strings manipulation into a single object be a single responsibility? How about grouping together all the service calls made within an application without an established approach to making these determinations? Adhering to the single responsibility can be a bit perplexing. Object role stereotypes. And object role stereotypes. One approach which can aid the organizational behavior within the system is the use of object role stereotypes. Those stereotypes are a set of a general pre-established roles which commonly occur across object-oriented architectures. By establishing a set of role stereotypes, developers can provide themselves with a set of templates which they can use as they go through the mental exercise of decomposing behavior into cohesive components. The concept of object role stereotypes is discussed in the book Object Design Roles, Responsibilities, and the book presents the following stereotypes. Information folder. An object designed to know certain information, provide that information to other objects. Structure. An object that maintains relationship between objects and information about those relationships. Service provider. An object that performs specific work and offers services to others on demand. Controller. An object designed to make decisions and control a complex task. Mm. An object designed to make decisions and control complex tasks. Coordinator. An object that doesn't make many decisions but in a rote or mechanical way delegates work to other objects. Interface is an object that transforms information or requests between distinct parts of a system. While not pres- prescriptive, this set of role stereotypes provides an excellent mental framework for aiding in the software design process. Once you have established set of role stereotypes to work within, you will find it easier to group behaviors into cohesive groups of responsibilities related to the object's intended role. Information holder, designed to know certain information and provide that information to other objects. Structure, an object that maintains relationships between objects and information about those relationships. Tense relationships between objects and information about those relationships. Service provide an object that performs specific work and offers services to other on demand. Controller, an object designed to make decisions and control a complex task. Coordinate, an object that doesn't make any decisions but in a rote mechanical way delegates work to other objects. Это вообще как? Как это реализовать? Что за бред? Interfacer, an object that transfers information or requests between distant parts of a system. Окей. Once you have established set of role stereotypes to work within, you will find it easier to group behaviors into cohesive groups of responsibilities related to the object's intended role. Совмещенные, сплоченные. No. Single responsibility principle example. To illustrate the application of the single responsibility principle, let's consider the following example which facilitates the movement of product items into a shopping cart. This get ID function return ID. Product. Okay. Um, okay. Reynolds of the complexes. This example illustrates a number of unrelated responsibilities which are grouped together within a single anonymous function. Let's consider each responsibility. First, we have behavior defined to handle populating the cart model when an item is double-clicked. Second, we have behavior defined to add items to the cart view when an item is double-clicked. Third, we have behavior defined to populate the product view with initial set of product. Let's break these three responsibilities into their own objects. Okay. Event prototype handler. Type key. This name from the name. Event prototype handler. Блин, я уже забыл конструкторы. Конструктор. Точно. Handler. This handler's push handler. Function. Handler. Event prototype file. Get event. Mm, Events. Так. Now revised. We have removed our anonymous function and replaced it with objects to coordinate each of the separate responsibilities. Card view was introduced to coordinate the population. Mm-hmm. Я все равно не понимаю. Event name. Turn publish, subscribe. Что это вообще такое? Это все, я понял. Return publish. Не понял. Event name, event arguments. Get event name, fire. This add item. Event aggregator. Mhm. We removed our anonymous function and replaced it with objects to coordinate each of the separate set of responsibilities. A card view was introduced to coordinate the population of the card display. A card controller was introduced to coordinate the population of card model. And the product view was introduced to coordinate the population of the product's display. We also introduced an event aggregator to facilitate communication between the objects in a loosely coupled way. This design results in a larger number of objects. Each object now focuses on fulfilling a specific role within the overall orchestration with manual coupling between the objects. Next time we'll discuss the next principle in the solid acronym. Single responsibility. Here's the same topic. Has links to other very brief articles that covers the rest of solid. Consider them optional reading. This post is part of a series of posts on the solid principles for software development, specifically in JavaScript. You can find them all in the following links. The single responsibility principle says that a class or module should have only a single purpose. For example, if you have a wallet class, the class should only implement a wallet functionality. It's fine to call other functionality, but it shouldn't be written there. Let's look at the bad example in the code below. The car class has a single method start. When this method is called, the car may or may not start, depending on some logic which isn't included here, as it's not important. The class will then log some information depending on the outcome. But notice how the login functionality is implemented in the method of this class. Logic to determine whether or not the car should start. This error log. This error log. This violates the single responsibility principle because the logic for logging the information should not be responsibility of the car class. There are a number of readability and the code management issues that are caused by this, but the easiest issues to describe is actually refactoring. Let's say your logger logs to a file. Your logger logs to a file and this worked great for several months. Suddenly an update occurs on the underlying system and the car class is running on. And you need to change the way you write to files. Suddenly you now need to update every file writing instance of every class you have ever implemented a logger inside of. The task would be huge, but what if you would follow this single responsibility principle? Error log, static, log message, console log message, car, Constructor make model start error log. Uh, As you can see here, we wouldn't have this problem. The log is stored in a separate class, which means its functionality is separate to the car class. The car class can be changed, moved around, or even deleted without affecting the logger class. Likewise, if a change is required to the logger class, it only needs to be carried out in a single place. Нормально. Mm. The open closed principle says that code should be open for extension, but closed for modification. What this means is that if we want to add additional functionality, we should be able to do so simply by extending the original functionality without the need to modify it. To explain this, let's look at an example. Below we have a vehicle class. When the vehicle instance is created, we pass in the fuel capacity and fuel efficiency. To get our range, we simply multiply our capacity by our efficiency. Get range as new vehicles. Let's say we add a new type of vehicle, a hybrid vehicle. This vehicle doesn't just have standard fuel-based range; it also has an electric range, which it can use as well. To find out the range now, we need to modify our getRange method to check if a vehicle is a hybrid and add its electric range too. Constructor and this electric range. This violates the open closed principle because whilst adding our new hybrid vehicle class, we have had to go back and modify the code of our vehicle class in order to make it work going forward. Every time we add a new type of vehicle that might have different parameters for its range, we will have to continually modify the existing getRange function. Instead, what we could do is to override the getRange method in the hybrid vehicle class, giving the correct output for both vehicle types without ever modifying the original code. Mhm. Separate method that modifies the result from the parent class. This way should the formula to calculate the range for any vehicle change would only need to be updated in the parent class. In the same inside hybrid vehicle, we could do get range. List substitution principle states that any class should be substitutable. The list substitution principle states that any class should be substitutable. For its parent class, any class should be any class should be for its parent class without unexpected consequences. In other words, if the class cat and dog extend the class animal, then we would expect all of the functionality held within the animal class to behave normally for a cat and dog object. Classic example of list of substitution violation is the square and rectangle problem. This problem is posed. It is posed that the square class can inherit from a rectangle class. On the face of it, this makes sense. Both shapes have two sides and both calculate their area by multiplying their size by each other. But the problem arises when we try to utilize some rectangle functionality on a square object. Let's look at example. Rectangle. Correct. Correct. Set height. This example we initialize a rectangle and square and output their dimensions. So we then call the rectangle set height on the square object and outputs its dimensions again. What we find is that the square now has a different height than its length, which of course makes for an invalid square. This can be solved using polymorphism, an if statement in the rectangle class, or a variety of other methods, but the real cause of the issue is that square is not a good child class of rectangle, and that in reality perhaps both shapes should inherit from a shape class instead. Its parent class. This course should be open for extension. The interface segregation principle states that an entity should never be forced to implement an interface that contains elements which it will never use. The interface segregation principle states that an entity should never be forced to implement an interface that contains elements which it will never use. For example, a penguin should never be forced to implement a bird interface if that bird interface includes functionality relating to flying, as penguins cannot fly. Now this functionality is a little more difficult to demonstrate using JavaScript due to its lack of interfaces. However, we can demonstrate by using composition. Composition is a subject all by itself, but I will give a very high level introduction. Instead of inheriting an entire class, we can instead add chunks of functionality to a class. Here's an example that actually addresses the interface segregation principle. Object assign bird prototype flyer. New bird flyer. What this example does is to add a flying functionality or interface only to the classes that require it. This means that penguin will be given the ability to fly, whereas birds will. This is one of methods. This one method of adhering to the interface segregation principle, that is a fairly rough example. This does play well with interfaces. Dependency inversion. The dependency injections principle states that high-level code should never depend on low-level interfaces. Dependency injection principle states that high-level code should never depend on low-level interfaces and should instead use abstractions. It's all about decoupling code. Not following, I don't blame you, but it's surprisingly simple. Let's say we have a piece of software that runs an online store, and within that software, one of the classes purchase handler handles the final purchase. This class is capable of charging the user's credit card and does so by using a PayPal IP. Process payment. A complicated PayPal specific logic goes here. Payment success equals PayPal request payment amount. Return do something return false. Is that if I change from a PayPal to Square, another payment processor, it takes a month's time, this code breaks. We need to go back and swap out our PayPal IP calls for Square API calls. But in addition, what if the Square API wants different types of data, or perhaps it wants us to stage a payment first and then to process it once staging has completed? That's bad, and so we need to abstract the functionality out instead. Rather than directly call the PayPal API from our payment page, we'll instead create another class called payment handler. The interface for this call will remain the same no matter what underlying payment system we use. Even if the two systems are completely different, we'll still need to make changes to the payment handler interface. If we change payment processor, but our higher level interface remains unchanged. Process payment. Payment handler. Request payment. Payment handler. Request payment amount. And now you may be looking at this and thinking, but wait, there's way more code. And you will write like many other thought principles, and indeed all principles in general. The objective is less about writing less code or writing is quicker, and more about writing better code. The above change will save you days or maybe even weeks further down in line in exchange for spending a few hours out now. Что мне Т нажать? Ой. Okay. And for good measure. Окей. Окей. Так. Мы тоже сейчас прочитаем. Так. I have found a very good article explaining the solid principles. If you are familiar with PHP, you can read the original article here. But since I'm a JavaScript developer, I have adapted the code examples from the article into JavaScript. JavaScript is a loosely typed language. Yes, some consider it's a functional language, others consider it's an object-oriented language. Some think it's both, and some think that having classes in JavaScript is just plain wrong. This is just simple welcome to Solid article. It simply sheds a light on what Solid is. Single responsibility principle, open-closed principle. Open-closed principle, list of substitution principle, interface segregation principle, dependency inversion principle. A class should have one and only one reason to change, meaning that a class should only have one job. The class should have only one single purpose. A class should have one and only one reason to change, meaning that the class should only have one job. For example, say we have some shapes and we wanted to sum all the areas of the shape. Well, this is pretty simple, right? Circle radius type circle. Return object assign object create proto radius length equals proto square. First we create our shapes factory functions and set up the required patterns. What is factory function? JavaScript any function can return a new object when it's not a constructor, function, or class. It is called a factory function. Why to use factory functions? The article provides a good explanation. This video also explains it very clearly. Так, стоять. Медленнее. Closure это этот, замыкание. Sniffle stalk. Почему не будет работать? Sound wolf, talk, console log sound. Sniffles dog. Этот человек капец крутой. Нифига он. Люк Бессон. Ты. Да. Нет, не уходи. Нифига это было сколько? 7 лет назад. Жесть. Че он ушел? Окей. Ну, чел реально крутой. Жалко. Короче, Factory Functions лучше, чем ваши классы. Класс это вообще прикол. Using the array calculator factory function and then write up our logic to sum up the area of all provided shapes. Так. Creating the area calculator factory function and then write up our logic to sum up the area of all provided shapes. Proto sum logic to sum output. The area return object assign object create proto shapes as. Что-то не понимаю про вот это, что за приколы. Это sign, это я знаю, что типа можно возвращать. So you speak first you want to include in your new object. You want to go ahead and lump up all of the another object. And you can certainly do that as well with object assign. Mm. Mm, assign. That's true. Object create. Proto. Что такое object create? Методы. Mm, Mean name. Nephew. Yes. Um, mhm. Proto. Properties object. The object which should be the prototype of the newly created object, specified in nodes undefined. An object whose enumerable on property specify property descriptors to be added to the newly created object, with the corresponding property names. These properties correspond to the second argument of object defined properties. To use the area calculator factory function, we simply call the function and pass in an array of shapes and display the output at the bottom of the page. Logic to sum. Const shapes, circle, square, square. Что за цифра? Area calculator, shapes, console log area output. Sum of the area of provided shapes. This sum. The problem with the output method is that the area calculator handles the logic to output the data. Therefore, what if the user wanted to output the data as JSON or something else? All of the logic would be handled by the area calculator factory function. This is what singular responsibility principle frowns against. Сражается, мурит. Frowns against the area calculator factory function only sum the area of provided shapes. It should not care whether the user wants JSON or HTML. So to fix this, you can create an sum calculator outputter factory function and use this to handle whatever logic you need on how the sum areas of all provided shapes are displayed. So to fix and this, you can create in some calculator outputter factory function and use this to handle whatever logic you need on how the sum areas of all provided shapes are displayed. The same calculator outputter factory function would work like this. Like this. Areas. Area calculator shapes. So calculator. Um, areas. Areas это объект. Okay. Now whatever logic you need to output the data to, the user is now handled by the sum calculator outputter factory function. Objects or entities should be open for extension but closed for modification. Open for extension means that we should be able to add new features or components to the application without breaking existing code. Closed for modification means that we should not introduce breaking changes Should not introduce breaking changes or existing functionality because that would force you to refactor a lot of existing code. In a simpler words, means that class or factory function in our case should be easily extendable without modifying the class or function itself. Let's look at the area calculator factory function, especially its sum method. Reduce 0. Что такое VC? We wanted the sum method to be able to sum the areas of more shapes. Would have to add more if-else blocks, and then goes against the open-closed principle. A way we can make this sum method better is to remove the logic to calculate the area of each shape out of the sum method and attach it to the shape's factory functions. Const prototype square math power this length 2. Return object assigned length. Типа не выписывать все. Я понял. The same thing should be done for the circle factory function, and area method should be added. Now to calculate the sum of any shape provided should be as simple as the same thing should be done for the circle factory function. The circle factory function. Area method should be added. Now to calculate the sum of any shape provided should be as simple as то есть The same thing should be done for the circle factory function. Area method should be added. Now to calculate the sum of any shape provided should be as simple as... Так нужно чуть больше написать. Но зато... Да, прикольно. Area push. Так, now we can create another shape class and pass it when calculating the sum without breaking our code. However, now another problem arises. How do we know that the object passed into the area calculator is actually a shape? What if the shape has a method named area? As a shape class and pass it when calculating the sum without breaking our code. However, now another problem arises. How do we know that the object passes into the area calculator is actually shape? Or if the shape has a method named area, coding to an interface is an integral part of Solid. A quick example is we create an interface that every shape implements. Since JavaScript doesn't have interfaces, I'm going to show you how this will be achieved in TypeScript, since TypeScript models are the classic hope for JavaScript, and the difference with pure JavaScript prototype or interface shape interface area number class circle implements shape interface radius number 0. This radius equals r. Public area number. The example above demonstrates how this will be achieved in TypeScript. Demonstrates how this will be achieved in TypeScript, but under the hood, TypeScript compiles the code to pure JavaScript, and in the compiled code it lacks of interfaces since JavaScript doesn't have it. So how can we achieve this? In the lack of interfaces, function composition to the rescue. First we create shape interface factory function, as we are talking about interfaces. Our shape interface will be as abstracted as an interface using function composition. The resource shape interface will be as abstracted as an interface using function composition. Уже смотрели. Shape interface state. Shape interface area state area. And then we implement it to our square factory function. Area state area state. Исходит. Then we implement it to our square factory function. Basics shape interface proto. Composite object assign basics. Object create composite length. Proto. Что происходит? Proto length type square area shape interface proto создает объект, который мы засовываем прото. State, area, state. Что значит state? Прото. Прото. Area. Вот и чё. The result of calling the square factory function will be the next one. Что происходит? Square 5. Вот откуда вот это берется? Вот отсюда что ли? Что за arcs? Console locked. Output object. Proto. Get prototype of type. Shape interface. Area function area. In our error calculator sum method, we can check if the shape provided actually types of shape interface. In our area calculator sum method, area calculator sum method. In our area calculator sum method, we can check if the shapes provided are actually types of shape interface. Area calculator sum method, we can check if the shapes provided are actually types of shape interface. Otherwise, we throw an exception. If object get prototype of shape type on a shape interface, and again, since JavaScript doesn't have support for interfaces like typed languages, this example above demonstrates how we can simulate it. More than simulating interfaces, what we are doing is using closures and function composition. If you don't know what are a closure, this article explains very well. Mix-up substitution principle. Let QX be a property provable about objects. Be a property provable about objects of X of type T. Then QY should be provable for objects Y of type S, where S is a subtype of Chua. Let QX be a property provable about objects of X. To be a property provable about objects of X of type T. Then should be provable for objects Y of type S, where S is a subtype of T. of type S, where S is subtype of T. What this is stating is that every subclass derived class should be substitutable for their base parent class. This stating is that every subclass derived class should be substitutable substitutable for their base parent class. In other words, as simple as that, a subclass should override the parent class method in a way that does not break functionality from a client's point of view. As simple as that, the subclass should override the parent class method in a way that does not break functionality from a client's point of view, still making use of our area calculator factory function. So we have a volume calculator factory function that extends the area calculator factory function. And in our case, for extending an object without breaking changes, in ES6 we do it by using object assign and object get prototype of. So making use of our area calculator factory function, say we have a volume calculator factory function that extend the area calculator factory function. And in our case, for extending an object without breaking changes. In case for extending an object without breaking changes, we do it by using object assign and the object prototype of. Area cal proto. Inherit object assign. Area object assign. Object get prototype of area calculator. Um, um, Object assign. Create inherit shape as. Interface segregation principle. Mm. Says any class should be substitutable for its parent class without unexpected consequences. Substituted это извлечен или что? Блин, я забываю. Взаимозаменяемый. Subclass should be sub. What as simple as that, a subclass should override the parent class method in a way that does not break functionality from a client's point of view. A client should never be forced to implement an interface that it doesn't use, or clients shouldn't be forced to depend on methods they do not use. Continue with our shapes example. We know that we also have solid shapes. So since we would also want to calculate the volume of shape, we can add another contract to the shape interface. Shape interface state. Shape interface state type shape interface. Must implement shape we create must implement the volume method. But we know that squares are flat shapes and that they do not have volumes. So this interface would force the square factory function to implement a method that it has no use of. Interface segregation principle says no to this. Instead, you could create another interface called solid shape interface that has the volume contract, and solid shapes like cubes can implement this interface. Shape interface. Solid shape interface. Что вот это значит, я не понимаю. Area — это функция, которая берет state, точка area state. Чё, как оно себя вызывает? Solid shape interface. Solid shape interface. Solid shape interface volume. Solid shape interface. const cubo length, const proto length type cubo, area arcs, volume, const basics shape interface proto, complex, composite. This is a much better approach, but a pitfall to watch out for is when to calculate the sum for the shape instead of using the shape interface or the solid shape interface. You can create another interface, maybe manage shape interface, and implement it in both the flat and solid shapes. You can create another interface, maybe manage shape interface, and implement it on both the flat and solid shapes. You can create another interface, maybe manage shape interface, and implement it both on both the flat and solid shapes. This is where you can easily see that this has a single API for managing the shapes, for example. Const proto radius. Abstraction. Что вообще происходит? Basics area. Complex volume. That's composite. As you can see, until now what we have been doing for interfaces in JavaScript are factory functions for function composition. And there with manage shape interface, what we are doing is abstracting again the calculate function. Or what we're doing here, and in the other interfaces, if you can call it interfaces, we're using high order functions to achieve the abstraction. We do. Mhm. Перекус бананом. Мгм. And this must depend on abstractions, not con concretions. Чё, блин? It states that the high-level module must not depend on the low level module, but they should depend on abstractions. As dynamic language, JavaScript doesn't require the use of abstractions to facilitate the coupling. Doesn't require the use of abstractions to facilitate decoupling. Therefore, this stipulation that abstraction shouldn't depend upon details isn't particularly relevant to JavaScript applications. The stipulation, блять. Оговорка. Stipulation, оговорка. That high-level modules shouldn't depend upon lower-level modules is however irrelevant. Dependency injection principle states that high-level code should never depend on low-level interfaces. It should instead be use abstractions. From a functional point of view, these containers and injections Concepts can be solved with a simple higher order functions or roll in the middle type pattern, which are built right into the language. How is dependency inversion related to higher order functions is a question asked. It's like a chance if you want to deep explanation. This much should bloat it, but it's really easy to understand this principle also for decoupling. And we have made it before. Let's review our code with the manage shape interface and how we accomplish the calculate method. What the manage shape interface function receives is the argument is a higher order function that decouples for every shape the functionality to accomplish the needed logic to get to final calculation. Let's see how this is done in the shapes objects. Manage shape interface, basics area, construction, manage shape interface, manage shape interface, basic area, complex volume. For this square, what we need to calculate is just getting the area of the shape, and for a cube, what we need is summing the area with the volume, and that is everything needs to what the coupling and get the abstraction. If you take the solid principle to their extremes, you arrive at something that makes functional programming look quite attractive. JavaScript is multi-paradigm programming language, and we can apply the solid principles to it, and the great of it is that we can combine it with the functional programming paradigm and get the best of both worlds. JavaScript is also a dynamic programming language and very versatile. That I have presented is just a way of achieving these principles with JavaScript. They may be more better options in achieving these principles. I hope you enjoyed this post. I'm currently still exploring the JavaScript world, so I'm open to accept feedback or contributions. How to write highly scalable and maintainable JavaScript coupling. The summary of most common building a house from the inside out. Это я уже читал. How to write highly scalable and maintainable JavaScript coupling. The Wild West syndrome, namespacing modules and coupling. In the previous chapter in this series, we described modular JavaScript. We looked at native patterns, some of the prominent and formats such as AMD, CommonJS, etc. In this final chapter, we'll examine ways to reduce coupling between JavaScript modules. Это соединение, правильно? Связь. Coupling between modules occurs when one module directly references another module. In other words, one module knows about another module. For this chapter, assume that we are building a web application that allows people to place food delivery orders. Each time the user places an order, the app creates the order and sends a confirmation to the user that includes the estimated time of delivery. The user can check the status or cancel the order at any time. One modular approach to implement this is to create a module that handles orders. One modular approach to implement this is to create a module that handles orders and another that handles deliveries. To implement this is to create a module that handles orders and another that handles deliveries. The ordering module may have functions to create, read, update, and delete orders. While the deliveries modules may have functions to estimate delivery time, begin delivery, complete delivery, and so on. Let's look at an example implementation. Note that the code in this post is written primarily for clarity. Create order. Order module definition. Order modules. Order module. Deliveries. My app delivery module. Module create order. Yeah. Module create order. I don't know, function. Order data. Order results. Так, create order. Function order data. Order result. Order result равно code to actually create the order. Order result estimate delivery time равно deliveries get delivery time order data. Return order results. The order and delivery modules shown are tightly coupled. For the order module to get the estimated delivery time, it has to know about the delivery module and call the appropriate modules API. There are many reasons to avoid tightly coupling your modules. We discussed some of this in the first chapter of this series. Recall that one of the goals when creating highly scalable in maintainable JavaScript application is that any module can be easily swapped out at any time for different modules. Reusability. There are many reasons to wait tightly coupling your modules. We discussed some of this in the first chapter of this series. Recall that one of the goals when creating highly scalable and maintainable JavaScript application is that any module can be easily swapped out at any time for a different module. Reusability is also a major reason to minimize coupling. Ideally, we would like to maximize code reuse and the ability to test modules independently. Another goal was that there should not be a single point of failure anywhere in the application. Another goal was that there should not be a single point of failure Our goal was that there should not be a single point of failure anywhere in the application. Suppose that something went wrong in our call to get the estimated delivery time. This may break the entire application or at least the successful completion of the ordering process. We should prefer that the order is still placed, the application continues to operate, and if we are temporarily unable to provide a delivery time estimate. Another goal was that there should not be a single point of failure anywhere in the application. Suppose that something went wrong in our call to get the estimated delivery time. This may break the entire application. That something went wrong in our call to get the estimated delivery time. This may break the entire application. This may break the entire application. There should not be a single point of failure anywhere in the application. Suppose that something went wrong in our call to get the estimated delivery time. This may break the entire application or at least the successful completion of the ordering process. We should prefer that the order is still placed and the application continues to operate, even if we are temporarily unable to provide a delivery time estimate to a customer. Now let's examine some ways to reduce coupling between modules. Patterns to reduce coupling. Tightly coupled modules have a variety of disadvantages as noted. Luckily, there are ways we can reduce coupling, which includes many patterns used to achieve loose coupling between modules. These patterns are often a variation of the so-called observer pattern. One such variation is referred to as the pub-sub or publish-subscribe pattern. In some cases, the observer register itself with the event emitter directly in order to be notified whenever a certain event occurs. The downside to this approach is that an observer knows about the event emitter object and what observables or events to observe through the registration process. We can do better. There are many versions of the pub/sub pattern that involve a mediator object, which helps to further minimize coupling between modules. Mediator object is an object that isolates as a publisher from a subscriber. Arias Money made an excellent analogy when he related the mediator to a flight control tower. In earlier, excellent analogy when he related the mediator to a flight control tower in airplane communications. Airplanes never communicate directly with each other. Airplanes instead only provide information to and receive information from the tower, and therefore do not know about the one another without information from the tower. There are a variety of libraries available to implement pub/sub type patterns. We will use pub/sub.js from which is a topic-based JavaScript pub/sub library and can be found here. Topic-based simply means that there are topics that the module can either subscribe to, publish to, or both. A module is also able to unsubscribe from a topic if needed. We'll now revisit our example from before, but instead implement it using pub/sub.js. Here's the code. Event listener DOM content load function. Event order module function orders current estimated delivery time. Pub/sub subscribe as delivery function. Function deliveries. Deliveries get estimated delivery time of function. Estimated delivery time 1 hard coded to 1 hour, but likely an AP call. Pub/sub publish. Tag okay. For simplicity, all required code in both module definitions are included in the same document ready event handler. Here we define two modules, one for orders and the other for deliveries, respectively. Notice that we have defined a topic with the isDelivery constant called. That we have defined a topic with the isDelivery constant called current estimated delivery time any module can publish. That we have defined a topic with the isDelivery constant called current estimated delivery time any module. We have defined a topic with the sDelivery constant called current estimated delivery time. Any module can publish and or subscribe to this topic without knowing of each other's existence. In this case, we have directly called the getEstimate delivery time method of a delivery module. By calling this method, the delivery module is used to retrieve the current estimated delivery wait time, which is likely based on the number of delivery orders currently in the queue, and then publishes the expected estimated delivery time to the S delivery topic. At this point, any subscriber to this topic will be notified of the uploaded and latest delivery time estimate. The order module subscribes to the topic. It will therefore always have the most up-to-date estimated delivery wait time to use when orders are placed, but without having to know about the delivery module and its method, events, and so on. We can go a step further and implement a mechanism that regularly updates and publishes the estimated delivery wait time to this topic on regular intervals, or each time an order is placed and the queue is changed. Just one example of the many ways to use the publish subscribe pattern to your advantages. There are, however, some potential downsides to this level of loose coupling, and I encourage you to read some of the resources noted for further description matter. Throughout this series, we have discussed ways to write highly scalable and maintainable JavaScript code, as well as covered some industry best practices and patterns used to achieve this goal. We also discussed the Wild West syndrome and why it's important to consider proper JavaScript code design, architecture, organization, and coupling. We consider patterns such as namespacing in modules, as well as the various ways to implement modules using plain JavaScript or by using the specification format such as AMD. In this final chapter, we discussed coupling between modules and ways to minimize it. Patterns such as the observer and or variation of publish subscribe are excellent choices for reducing coupling. Loose coupling is very important for promoting code reuse, independent testability, interchangeability, and protection against a single point of failure. When the above goals and techniques are considered and executed properly, your JavaScript code can most certainly be highly scalable, maintainable, usable, reusable. Так, explain the single responsibility principle. Что типа одна функция должна отвечать за одно действие, один класс должен отвечать за одни какие-то связанные с собой параметры и не выполнять ничего другого лишнего. It says that the class or module should have only a single purpose. Class should only implement valid functionality. Да. Briefly explain the additional sort principle. Вот это я вообще не понял, честно. Нифига мне выписывает. Нифига мне выписывает, блин. In software development, when we talk about tightly coupled objects, we're referring to designs or implementation where two or more objects are highly dependent on each other. Объекты. This means that changes made to one object may require corresponding changes in the other objects, leading to a high level of independence. Tightly coupled objects often have direct knowledge of each other's internal workings and rely on specific interfaces or implementations of other objects to function correctly. They tend to have a lot of dependencies, making it difficult to modify or extend the system without impacting multiple components. Here are a few reasons why tightly coupled objects are generally considered desirable. То есть tightly coupled объекты — это те объекты, которые зависят друг от друга очень сильно. Reduce flexibility and modifiability when objects are tightly coupled. Making changes to one object often requires modifying other dependent objects. This can lead to a cascade of changes throughout the system, making it difficult to add new features or fix bugs without affecting the entire code base. Lower reusability and testability. Tightly coupled objects are challenging to reuse in other parts of the code or in different projects, since they really rely heavily on specific dependencies. It becomes harder to extract and isolate them from independent testing or reuse. This can limit code modularity and higher unit testing efforts. Are challenging to reuse in other parts of the code or different projects. Increased complexity and understanding. As the number of dependencies and interconnections between objects grows, the overall complexity of the system increases. It becomes harder to understand how different objects interact with each other, leading to this decreased readability and maintainability of the code base. Limited scalability. Tightly coupled systems often struggle with scalability. When a system needs to handle increased loads, will be extended to accommodate new requirements. The interdependencies between objects can make it challenging to distribute the workloads or add new components without causing disruptions. In these issues, it is generally recommended to aim for loosely coupled design. In a loosely coupled system, objects have minimal knowledge of each other and interactions are typically based on well-defined interfaces or contracts. This promotes modularity, flexibility, and user maintenance, allowing objects to be modified, tested, and reused more effectively. The additional solid principles. Open-close. The open-close principle said the code should be open for extension. Open-close, то есть мы должны писать код так, чтобы если мы внедряем какие-то новые функции, то мы могли их внедрять без изменения каких-то корневых элементов. states that class should be substitutable for its parent class without unexpected consequences. In other words, if the class cat extend this, we then would expect all of the functionality held within the animal class to behave normally. List of substitution. Где этот Лисков? Это где я читал? It's simple as that a subclass should override the parent class method in a way that does not break functionality from. То есть мы должны переписывать в, в новой функции или в новом объекте parent функцию. Interface segregation. Principle states that as an entity should never be forced to implement an interface that contains elements which it will never use. Интерфейс-сегрегация заключается в том, чтобы объектам не присваивать элементы там всякие, которые они не будут использовать. Dependency inversion. The dependency injection principle states that high-level code should never depend on level interface and should instead use abstraction. It's all about decoupling code. То есть мы должны писать так, что если что-то в будущем поменяется, то мы смогли поменять в одном месте, и в этом в одном месте изменит все остальное. Мы почитаем в следующий раз.